Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. This is the first video, guys, where I'm tackling the question paper from the province of KwaZulu-Natal. Yes, I'm doing a mid-year examination. Please do expect a total number of 10 videos, since the question paper has 10 questions in total. And please, guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year examination, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. Okay, first question you're supposed to solve for x. Now, 1.1.1, we are given three things that are multiplied and the answer is 0. So if ever, guys, you have things that are multiplied and the answer is 0, we'll simply use the rule that simply says if a multiplied by b multiplied by c is equal to 0, it's either a is 0 or b is 0 or c is the one which is 0, right? Either one of the three things that are multiplying one another are equal to 0. So over here, I'll simply say 5x is equal to 0, or 2x plus 7 is equal to 0, or 8 minus x is equal to 0. Then all I have to do now is to just isolate x in all of these equations. So I have 5x equal to 0. I just need to divide by 5 on both sides. Therefore, x will be equal to 0. Over there, I'll be left with 2x is equal to negative 7. And then x is basically negative 7 all over 2. Or I'll have negative x is equal to negative 8. Then x will just be a positive 8. So my roots are x is 0, or the second one, x is just negative 7. X is just equal to negative 7 over 2. And then the third one, x is just equal to 8. Okay? And then 1.1.2, we are supposed to solve x. We are given a quadratic equation which is already on standard form. So all we have to do, guys, is to just factorize out together. I simply have x squared plus 13x plus 12 is equal to 0. I'm looking for the factors of 12 that when I add will give me 13. And those factors are 12 and 1. So since my constant term is positive, I know that my brackets will just have the same sign, but not just any sign, the sign of the middle term. So I'll simply have plus and plus over there. So therefore, I'll simply have x is equal to negative 12, or x is equal to negative 1. So x is just negative 12, or x is negative 1. Okay, and then for 1.1.3, I'm supposed to solve x. And yes, I do have a quadratic equation. And if, guys, I cannot find the factors, all I need to do is to find my is to use my quadratic equation, right? It simply says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Then all I have to do, guys, is to just substitute. B is just negative 7 plus or minus the square root of negative 7 all squared minus 4ac all over 2a. Whenever, guys, you punch your calculator, you will see that it will say math error, which simply means that this equation does not have real roots. So you'll simply say there's no solution. There's no solution over there. Now, okay, now let's go to 1.1.4. We are given an equation which is in set form. We are supposed to solve for x. All we have to do is to make sure that we remove the sets. But before you remove the sets, there are things that we need to do. The first thing we need to do is to isolate the set that we want to remove. So on the left hand side, I'll be just left with x, the square root of x minus 2 is equal to x minus 2. Then for me to remove the sets, all I have to do is to just square both sides. And then on the left hand side, the square root will be cancelled. And then I can open two brackets on the right hand side. I'll end up having x squared minus 4x plus 4. And then I must make sure that my equation is in standard form. I'll simply have x squared minus 4x. I have a plus 4 over there equal to 0. Then the terms which are on the left hand side, whenever I take them to the right hand side, their signs will change. The x was positive there, but now it will be negative, and the 1 was negative, the 2 rather was negative, but now it will be positive. It will be positive, and therefore I'll end up having x squared minus 5x plus 6 is equal to 0. I'm looking for the factors of 6 that when I add will give me 5, and those factors are just 3 and 2. Since the sign here is positive, it simply means my brackets will have the same sign, but not just any sign, the sign of the middle term. So I'll simply have negative and negative, then x is basically equal to 3, or x is equal to 2. So these are the roots of my solutions, the roots of my equation, right? X is equal to 3 or x is equal to 2. Okay, now I'm given an inequality expression which I'm supposed to solve. Solving an inequality, guys, is similar to solving a quadratic equation. Are you together? The only difference would be on how I express my final answer. So since I have x, open bracket, x minus 1 is less than 20, the same procedure I would have done in solving a quadratic equation, I'll apply it over there. Nah? The first thing I need to do is to remove the brackets. How can I do so? By just multiplying everything inside the bracket by x over there. I'll end up having x squared minus x is less than 20. Then I must make sure that my inequality expression is in standard form. Therefore, I can simplify the factors over here. I'm looking for the factors of 20 that when I subtract will give me 1. So those factors are 5 and 4. Since the sign over there is minus, it simply means the two brackets will have different signs. So the biggest factor is the one that is going to take the sign of the middle term. So the sign of the middle term is minus, and the bigger factor between 5 and 4 is 5. So the sign of the middle term will come there, and then over there will be the alternate sign. And then I must write down my critical values. What are critical values? Critical values are the values of x that when I substitute on this expression over here will give me 0. I know that when x is equal to 5, I'll simply get 0, and whenever x is also equal to negative 4, I'll simply get 0. Then all I have to do, guys, is to express this, is to write down my critical values on my number line. I'll have negative 4 and 5. They are both not included because there's no equal sign there. So I'll keep them like this, né? And then the signs that I should write over there, guys, they depend on the signs which are multiplying x. Both of the coefficient of x have the same signs. Are you together? In this case, they are both positive. That means I must write a plus over there. And whenever, guys, I jump a critical value, this sign will change. Are you together? I'll write a plus, minus, and a plus. But from this step over here, I'm looking for an answer that will give me something which is less than 0. Less than 0 is negative, right? Where do I see negative on my number line? When x is between negative 4 and 5. When x is between negative 4 and 5. That's where I can see the negative on my number line. Okay, then question number 2, I'm supposed to solve an exponential equation. An exponential equation, okay? Let's create room for us to write over there. Okay, we have 2 multiplied by 2 to the power 1 minus 2x rather, plus 7 times 2 to the power negative x minus 4 is equal to 0. All I have to do, guys, is to remove, or rather, not removing anything rather. Whenever, guys, I come across plus and minuses between my terms, if I'm supposed to solve x and x is at the exponent, the first thing that I should do is to make sure that I separate my exponents. Né? Which rules am I going to use whenever I'm separating my exponents? There's a rule that simply says, if ever I have a to the power m divided by a to the power n, I can rewrite this thing as a to the power m minus n. Are you together? And the other rule that I'll apply there is the one that says 1 over a to the p is basically equals to a to the negative p. Okay, how can I separate these exponents over there? They are subtracting one another. These are just subtracting one another. So if my exponents are subtracting one another, it simply means that I had terms of the same bases dividing one another. So I'll simply have 2 to the power 1 divided by 2 to the power 2x, plus I have 7 multiplied by 1 all over 2 to the x, minus 4 is equal to 0. And then this thing can be written as 2 all over 2 to the power 2x plus 7 over 2 to the x minus 4 is just equal to 0. Yeah? The minute, guys, you have separated your exponents, it's either you can take out a common factor or just use the K method. Yeah? Let me tell you, if ever you have a constant term, please, guys, just use a K method. Are you together? Just say let 2 to the power x to be equal to k. So I'll simply have 2 to the power, over there I have 2 to the power 2x. That means I have k squared over there plus 7 over k minus 4 is equal to 0. Therefore, for me to remove these fractions, I must multiply each and every term by the LCD. My LCD is just equal to k squared. Are you together? So whenever I multiply each and every term by k squared, I'll be left with 2 plus 7k minus 4 k squared is equal to 0. And then now I can divide everything by negative 1. I'll simply have positive 4k squared minus 7k minus 2 is equal to 0. I can therefore factorize over there. I simply have 4k, k, 2 and 1, minus and plus. Then k is basically negative 1 over 4, or k is just equal to 2. But remember, guys, I was not solving for k. K was just helping me to get to the solution quicker. So whenever I come across k, I need to substitute 2 to the power x back. So I'll simply have 2 to the power x equal to negative 1 over 4, or 2 to the power x equal to 2. Over here, I do not have any solution because there's no value of x that I will substitute there and get a negative answer. So I'll simply say there's no solution. The only solution will be found over there. Remember that, guys, whenever I'm solving x, the first thing I need to do is to make my bases to be the same, right? So my bases are the same, so that simply means exponents should be equal. So the final answer over there is just x is equal to 1. Okay, and then now we are told that the roots of a quadratic equation are given by that. If m is an integer, determine the largest value of m for which these roots will be rational. These roots will be rational, guys, if and only if delta or the discriminant is greater or equal to 0. Are you together? My roots are rational if the discriminant is greater or equal to 0. Okay, my discriminant is everything inside that square root over there. Are you together? So that means 22 minus 3m should be greater or equal to 0. That means negative 3m should be greater or equals to negative 22. Therefore, m is less or equal to 22 over 3. Whenever I divide both sides by a negative number, the sign of the inequality changes. So 22 over 3 is basically equal to, that means m is less or equal to 7.33. So since, guys, I was told that m is an integer, are you together? Since I was told that m is an integer, that simply means I must just pick the first integer which is less than 7.33. That means the first integer will simply be 7. So when m is equal to 7, my roots will be rational. You can try that, guys. Nah? You can try, just substitute 7 over there. Believe me, your roots will be rational. Nah? Rational roots, guys, are answers that does not have square roots. Are we together? So whenever you substitute your m as 7, you'll find an answer that does not have a square root. Okay. 1.3, I'm supposed to evaluate that expression over there. The trick over here, guys, is to make every term to have the same exponent. I'm given the square root of 9 to the power 2024 all over the square root of 9 to the power 2023 minus the square root of 9 to the power 2025. Let me confirm. 2024, 23, 25. Okay. After doing that, guys, please identify the base with the smallest exponent. The smallest exponent is 2023. So I must try to change each and every exponent to look like this one. Are we together? So all I have to do is to say I have 9 to the power 2023 plus 1. Let me write properly there. 2023 plus 1. 2023 plus 1 will simply give me 2024, right? And then over there, I still have 9 to the power 2023. And then over there, I'll say 9 to the power 2023 plus 2. Are you together? And then there's a rule that says, guys, if you ever have two things multiplied, and then all you have to do is to just take one base and then add your exponents. Are you together? But right now, I'm going to reverse this rule over there. Yeah? If ever my exponents are adding, it simply means that my bases were multiplying. So inside the bracket, I simply had 9 to the power 2023 multiplied by 9 to the power 1 all over 9 to the power 2023 minus 9 to the power 2023 multiplied by 9 to the power 2. Are you together? There's another rule, guys, whenever you work with sets, that says if you have two things multiplied under a square root, you can simply separate them. The square root of A multiplied by the square root of B. I'll do the same thing. That's 9 to the power 2023 multiplied by the square root of 9 all over the square root of 9 to the power 2023 minus the square root of 9 to the power 2023 multiplied by the square root of 9 squared. And then all I can do here, guys, is to take out a common factor. So 9 to the power 2023 multiplied by the square root of 9 is simply equal to 3. And then I'll take out the common factor at the bottom. 2023. Whenever I take out the square root of, when I take out 9 to the power 2023, I'll be left with 1 minus the square root of 9 squared is just 9. So these two will just cancel one another. I'll be left with 3 divided by a negative 8, which is just negative 3 over 8. So this thing over there is just equal to negative 3 over 8. That's how, guys, you're supposed to simplify that thing then. Eh? I might have taken long to answer this, but I wanted to make sure that there's no step I skipped for you to understand. Yeah? Okay, I'm supposed to solve simultaneously now. I'm given two equations. I'm supposed to solve simultaneously. Let me erase that. Simultaneous equation. Okay, the first equation simply says 3 plus y minus 2x is equal to 0. That's equation 1. I have 3 plus y minus 2x is equal to 0. That's the first equation. Equation 2 simply says 4x squared plus y squared minus 2xy minus 7 is 0. 4x squared plus y squared minus 2xy plus 7 is equal to 0. Minus 2xy minus 7 is 0. Okay, this is my second equation, guys. Then all I have to do is to create the third equation by simply identifying the easiest equation of the two. Are you together? The most simplest equation to manipulate is the first one. So I'll simply say from equation 1, y can be written as 2x minus 3. By doing this, I'm creating equation 3. And then I can therefore say substitute equation 3 in equation 2. Whenever I come across y, I just need to substitute that thing over there. Remember, I have 4x squared plus y squared minus 2xy minus 7 is equal to 0. Y is equal to 2x minus 3, right? That's 2x minus 3. And then all I have to do now is to remove the brackets. I'll simply have 4x squared plus, whenever, yes, you can open two brackets and multiply them out, you'll end up having 4x squared minus 12x plus 9. And then over here I can simply remove my bracket as well. Negative 2x multiplied by 2x, that will give me negative 4x squared. Negative 2x multiplied by negative 3, that's positive 6x minus 7 is equal to 0. Okay, now let me group the like terms. I have 4x squared plus 4x squared, that's 8x squared minus 4x squared. I'll be left with 4x squared. Né? Then negative 12x plus 6x, this will give me negative 6x. Then 9 minus 7, I'll just get a positive 2 equal to 0. I can't divide each and every term over here by 2. I'll be left with 2x squared minus 3x plus 1 is equal to 0. I can therefore factorize this. That's 2x, x, 1 and 1. The sign there is plus. It simply means my brackets will have the same sign, but not just any sign, the sign of the middle term. That's minus and minus. Then x is just equal to a positive half, or x is equal to 1. So after finding the values of x, all I have to do is to go and find the corresponding values of y. So I'll simply say when x is equal to a half, therefore y is equal to 2x, x is 1 over 2, right, minus 3. This will simply give me a value of negative 2. And then when x is equal to 1, therefore y is equal to 2x minus 3. This will give me negative 1. So I know that whenever x is equal to half, its corresponding y value is negative 2. And whenever x is 1, its corresponding y value is a negative 1. Yeah, so that's how, guys, we're supposed to tackle this question over there and get your full 34 marks. Just stay tuned, guys, and wait for more videos. Thank you.